Alright, so in this video we are going to review the diamond box method. This method works best when you are dealing with an expression in quadratic form. And I say a quadratic form instead of a quadratic because not everything will be a quadratic that we can use this method for, but it will look like it. The other thing to make note of is this will work when we have a trinomial. So 3 terms to our expression. Now, a lot of you like to use trial and error when factoring a quadratic, and that's fine. However, when we have an a term that is larger than 1 or has many factors like a 12, it can sometimes make trial and error tough. Same thing here, when you're 14, you have multiple factors that would work. So, to review diamond box method, first we start by taking our a and our c terms and we multiply them together. In this case, we will get negative 168. We then will take a peek at our b term, which is negative 13. Place that in the lower part of the diamond, and that's how we'll get started. Now our goal is to find 2 numbers that multiply to get negative 168, but could add or subtract to get me to negative 13. From here, you can play with your calculator. 168 divided by 2, 3, 4, 6, 7, until you find those 2 numbers. So I will end up finding that 8 and 21 will get us to where we want to be. But then after that, we have to think through the negatives. And so to add to negative 13, that 21 will need to be negative. Okay, so what we just found are pieces of our box over here. We know that when we multiply our 2 terms out, that in the top left up here, we want to get 12x squared. And in the bottom right, we're going to get our c term, negative 14. So what that diamond helps us do is identify how many x's we will have that combine to get negative 13. And so we have negative 21x and 8x, and it shouldn't matter where you place these. From here, we're going to start filling out the sides. So you could start right here, for instance, and ask yourself, what is the greatest common factor between 12x squared and 8x? What's something that goes into both? And that would end up being 4x. 4x times 3x gives me 12x squared. 3x times a negative 7 gives me negative 21x, and 4x times 2 gives me 8x. You know that you did this correct if 2 times negative 7 is negative 14. My box makes sense. So we know that it factors into 4x minus 7, 3x plus 2. Okay, so for our examples, the first one, I probably wouldn't use the diamond box method because this is a 1. So you could just hop right into trial and error here. I know I need an x and an x to get x squared. I want to multiply to get 80, but add or subtract to get me to 24. 20 and 4 I know multiply to 80, but since I want negative 24, I need to make both of them negative. Let's go ahead and move down to example number 2. We'll start with the diamond. 3 times negative 5 will give me negative 15. My middle term is negative 2. So I want to multiply to get negative 15, add or subtract to get me to a 2. 5 and 3 will get us there, with the 5 being negative. From here, we can now take our information and place it into a box. I know top left, we went 3x squared. Bottom right, we went negative 5. Again, what we're searching for when we do the diamonds are our x values. And so we know that we will have a negative 5x and a 3x. These have a 3x in common. 3x times x is 3x squared. X times negative 5 would give us negative 5x. 3x times 1 would give us 3x. So it factors into 3x minus 5, x plus 1. Okay, next we'll go ahead and move on to example 3. And so same idea, a times c. That will end up giving us 294. And we want to add to 7. Again, you're probably going to rely on your calculator. We don't know factors of 294. Take it divided by 1, 2, 3, 4, 5, 6, 7, all the way until you're finally going to get to those magical numbers 14 and 21. Place into the box. I know I need a 6x squared. I know I need a negative 49, 21x, 14x. Pull out the sides. So from here, 6x squared and 14x has a 2x in common. 2x times 3x is 6x squared. 3x times 7 is 21x. 2x times 7 is 14x. This one factors into 2x plus 7, 3x plus 7. Now, the last one is just a little bit different. You could go through, do diamond rectangle like we have been. However, we don't want to forget that greatest common factor is a method that we want to look at first a lot of times. And in this case, you could make this a lot easier to factor by first pulling out a 3. So once you pull out that 3, you're left with a 5x squared minus 9x minus 2. Also, when you're talking about factors of 5, you only have 5 and 1. Factors of 2, you only have 2 and 1. So it might be in one where you could do trial and error now instead of that diamond rectangle method. For instance, I know that I have to have a 5x and an x to get 5x squared. I need to multiply to get a 2, so I could put the 2 here and the 1 here, or vice versa. But if I want to get to 9 x's, I want to put the 2 here, so I have 5x times 2 to get 10x. And then the 1 will be placed there, so I could make the 10 negative and the 1 positive to get to the 9x. Keep in mind, even though you factored out the 3, it does have to stay there. Okay, so moving to the second page, they're going to progressively get a little bit harder, and we definitely want to keep in mind that greatest common factor. And so on example 5, if you look at each of those terms, hopefully you'll identify that they all have a 2x in common. So we can pull out a 2x of each. We'll be left with a 5x squared plus a 19x plus 12. If you go into your diamond, you're now going to take 5 times 12. That 2x stays out front. It's still there, but we can ignore it for the time being. We want to multiply and get 60, add to get to 19. That will end up being 15 and 4. Put it into the box, same process. I'm not going to go through all of those steps now. You should end up with x plus 3 and 5x plus 4. Again, with that 2x staying out front. Okay, the next one we're going to take a peek at is we'll look at example number 6. And so same idea, look for a greatest common factor, however there isn't one. This is one of those cases where it's not a quadratic because the degree is a 4. However, it looks like a quadratic, so we can treat it that way. So we are going to use the diamond rectangle. 5 times 20 is 100. We need to add to 29, multiply to get 100, and we end up getting 4 and 25. We put that into the box. Now I need to multiply and get 5x to the 4th up top, multiply to get 20 on bottom here. And again, that box method helps us identify what goes here and here. Now this is the part that's going to be a little bit different. My middle term, these guys right here that combine to get 29, are now x squareds instead of just x's. 25x squared, 4x squared. Repeat this same process that we have been. These right here have a 5x squared in common. 5x squared times x squared is 5x to the 4th. 5x squared times 5 is 25x squared. X squared times 4 is 4x squared. This will factor into x squared plus 5 times 5x squared plus 4. Okay, next one here, again, look for greatest common factor. We don't end up seeing one. This is another one just like example number 6. looks like a quadratic. It's in that form, however, it's a 4th degree polynomial. Put it into the diamond rectangle. What you should end up getting from here is 2x squared plus 3, x squared minus 9. I want you to put a star on this one. This is one that we will come back to once we've learned all of our methods of factoring, because it's not considered to be fully factored. It's good for now, but on your test it wouldn't be completely factored. Okay, last one that we're going to look at for diamond rectangle is example number 8. If you look at all of them, we do have a greatest common factor that we can pull out, and that ends up being 4x. Once we do that, we get 3x to the 4th minus 10x squared minus 8. Now what's left in here, once we ignore this 4x, is just like example 7 and example 6. So we could use the diamond rectangle to help. Once you do that, that 4x still stays out front, but you'll be left with 3x squared plus 2 times x squared minus 4. Again, this is another one I want you to put a star by. We'll come back to this later on and get that fully factored.